So any questions? So I posted a new ODP this morning. We're going to talk about everything you need to know to make that work presently. So we're going to take a break from flowcharting for now, and I want to talk about some Linux commands that we can use to do the kinds of things we're going to need to do for the first programming assignment, which I also posted this morning, but we'll talk about formally tomorrow. So I want to go through some Linux commands for doing programming-like things, and I want to talk about how to create a script that will execute a bunch of commands for us and work like a program. It's basically like a batch file in DOS, but a shell script in Linux. And all this is recorded, and I'll post on YouTube, so you don't have to furiously write down everything that you see, but the stuff that strikes you or seems important, go for it. So the first command you want to know about is echo, right? And echo, basically, you can type anything after this, and it'll just repeat whatever you put in after the word echo. So echo, hello Nick, and it says hello Nick. So that's a useful way to give prompts to a user, to say, here's a matchstick game, this is what we're going to do, or please enter a number, or whatever. And we can also use it to output variables. So what's a variable? In C, we say something like integer x, semicolon, and then we can say x equals 12. Okay, we don't usually declare what type of variables we're using in a shell script. It figures it out. It's sometimes called duck typing. If it looks like an integer and acts like an integer, it's probably an integer. So we can say something like x equals 123, and we've just created a variable named x. Okay. Now if I say echo x, it's just going to say x, because echo says exactly what you tell it to echo, right? But if I know that x is a variable and it's been given a value with this equal sign, and I want to see the value of that, the way you dereference that is a $sign. So if I say echo $x, it'll show me the value of that variable. And if I say x equals ha-ha, and I echo $x, it says ha-ha. And if I say x equals 1 plus 4, and I echo $x, it says 1 plus 4. It's very, very straightforward literal, okay? X equals something, it just makes it equal to that something. And when you say echo, it just echoes exactly what you ask it to echo, unless there's a $sign, in which case it does that replacement. So if I say something like echo the value of x is $x, it's going to say the value of x is haha. So wherever it sees a $sign in front of something, it looks for a variable with that name. If I echo $sign not a variable, it doesn't show me anything, because not a variable doesn't have a value. Make sense? Okay, so basic variables, basically echo statement, and we can put those together. Most important command in all of Linux, CalSay. CalSay is your friend, so what does CalSay do? It's a picture of a cow saying whatever you asked it to say. This is really useful. And if you say x equals 12, you can say CalSay $x, and the cow will tell you the value of x. Okay. So it's basically like echo, but with some bling. Do you know about the manual page command, man? So you can do a man on CalSay. And there's all kinds of options. You can specify what you want to use for the eyes. And I didn't tell you about the other ones. But anyway, you can turn it into a dragon and all kinds of other things. So that's a good one. Oh, you can turn it into the Borg too. Yeah. So that's fun to play with. There's a Borg cow. All right, so we can do basic things with the variables. We can give them values, we can output them, and so on. To write a program, we don't want to have to type a bunch of commands. We want to type in the name of a program, like my program, and have it execute a bunch of stuff. And if you've done batch files in DOS or Windows, this is the same idea. So let's write a script. So I'm going to call this my program. And I'm going to say echo, hello, this is my program. And then I'll have a laughing cow. Okay, so I've got my program. It's got 2 lines in it. What I'd like to do is execute these 2 lines and have it actually do what I'm asking it to do. And normally this is all you have to do, just say / and the name of my program. But it's not going to let me do that by default. Because that's kind of dangerous. If you accidentally typed in the name of a file and it started executing everything that was in that file as if it was a Unix command, that could get you into trouble if it was the wrong file, or if this was a copy of War and Peace and you started trying to execute every line of that as a Linux command. So by default, you can't run these scripts. Okay. So you know the ls command, right? Shows you what's in your directory. If you say ls-l, you get these extra pieces of information, including these first 10 fields, which show you the permissions on this file. And this basically says I can read the file, I can write the file, I'm not allowed to execute it. And other people in my group, which would be other students for you, can read, write, but not execute. And everybody else can read, but they can't write and they can't execute. So there's a peculiar Unix command we need to know, which is change mod. And for now, all you got to know is change mod space 755 space and whatever the program name is. And that makes it executable. So if I do that, and then I say my program, it'll go ahead and execute my program. So it reads each line from that file and it runs it as a Unix command. So it does my echo and it does my CalSay. So this is how we can start writing programs in shell scripts, right? So this thing, my program, is called a shell script. And I don't have to do the / in front. I think I set up your account so you don't have to either. But if you say my program and it says it can't find that, use a / my program like you do on CTech. All right, still with me? So programs, we can do output. We got to be able to do input also, right? Otherwise, the program just does the same thing every time you run it. So how do we do input? Easiest way is a read command. So if I say read x, and I say ha ha ha, and now I look at the value of x, it's equal to ha ha ha. So read space followed by the name of a variable will wait for you to type something in and hit enter, and whatever you typed in, that'll be the value of the variable. If I say read x and I type 45, and then I look at the value of x, it's 45. So we can change my program. We can say echo who are you.
That says how are you.
It does. Thank you. All right, so we can say who are you, and then we can read something from the user, and let's just save that in a variable called name. And then let's go ahead and say hello, whoever you are. So it says, hello, this is my program, who are you? So what's my name? Because I don't want the cow to know my real name.
Steve.
I'll be Steve. And it says, hello, Steve. All right. 4 lines. The first line was completely superfluous, right? This is a lot more code in C, right? You got to declare things, you got arrays of things, you got pointers, you got to do the scanf and the printf and all that crazy stuff, right? Really, really quick development platform. Okay. Very little error checking, so things can go awry pretty easily. A little harder to debug, not necessarily as portable, but for a quick and dirty, get on the air immediately kind of programming environment, shell scripting is great, right? And it's always available in Linux. Now, let's talk a little about shells in general. So what's a shell? A shell is just this program that's running right now that printed out bracket 2035. That's the command number, the number of the command I'm about to type in, and it's got a little blinking cursor sitting there, and it's waiting for me to type stuff. And if I don't type something, this will just kind of sit here forever. But if I eventually type something like date, and I hit enter, it will somehow know that I want to know what the date is, and it'll go off and it'll tell me, and then it prints another prompt and it waits for me again. Okay, this is a program that's running on the server right now, right? The server's some Linux machine sitting somewhere in the cloud, and this is a program running that's controlled from my keyboard and sends output to my display. And this particular program is something called bash. And bash is an example of what we call a shell. Shell is just a program that waits for commands and responds to them. And there are a lot of different shells available in Linux. So the original shell was SH, maybe not the original, but an original was SH. This was the Bourne shell, B-O-U-R-N-E. Bash is actually the Born Again shell, sorry. And it's an improved version of SH. CSH is called the C shell, and TCSH was, I don't know, some kind of enhanced C shell. A whole bunch of shells. We're going to stick with bash in this course. The details of syntax vary slightly from one shell to another. So a lot of what we're learning in bash, if you try to go into C shell, it's not going to work the same. But there is a different syntax that would work just as well. But we're sticking with bash. Bash seems to be a pretty popular one these days. Most installations seem to come up with that by default. But if I was in a different shell, like the C shell, and I tried to execute my program, it's possible that the shell I'm in doesn't understand the read instruction, right? That may be specific to one shell. So what I really want to make sure is that when somebody says my program, I want them to run these instructions through the bash shell, okay? And there's a way to do this. So where is bash located? It's located in /bin/bash. Do you talk about directories at all in 121? Like make dir, cd, that kind of stuff? Okay, so we'll talk about that more when we get to file systems. Basically, there's a directory called /bin. It has a file called bash. That's the bash shell. So here's what we want to do. Well, in the very beginning of any script that we write, if we want to make sure that it's run with the bash shell, you got to put something special in line 1. And it's a number sign followed by an exclamation mark followed by the name of the program that you want executed, /bin/bash. Right, and this must be the first line of the script. So a number sign is just a comment. Okay, it's like a // in C. It says ignore everything else on this line. So I can say number sign delete all my files, right? And it's just a comment. It's not paying any attention to what comes after that. But the one exception is when you write a program, a shell script, if you start with a comment that begins with an exclamation mark, it's going to use the thing that comes after the exclamation mark as the shell that it executes. So we usually want to put this as the first line of any script that we're writing, as long as we're writing in bash. This is referred to as a shebang for some reason. So that's always our first line, and it's not going to change anything when we try to run this.
Is there a space between the exclamation point and the...
I don't think you're allowed to have a space.
Okay.
I don't know. Let's find out. That seems to work, but I wouldn't put it in. And if you make a typo in here, right, you'll get weird things like bad interpreter, no such file or directory. All right, so the next thing is arithmetic, right? So I said x equals 12, echo $x is 12, echo $x plus 1, and it tells me 12 plus 1, because that's exactly what I asked it to do. Echo the value of x, and then a plus sign, and then a 1. So sometimes we want to actually do arithmetic. We want the shell to actually evaluate an arithmetic expression. So there's a weird syntax for that. And it's $, parentheses, parentheses. And then inside here you put some arithmetic expression. One warning about Bash, it is really, really, really picky about syntax. Spaces are critical. Okay, when we get to if statements, spaces are absolutely critical. If you forget a space, it'll like scream and throw up its arms, and it'll look like something horribly went wrong, right? But it's really just a missing space. So let's echo $paren x plus 1. That gives us 13. So once you say $paren and you put something in there, it looks like C. Okay, it does the usual order of operations, plus, minus, times, that kind of thing. And we can do modulo operations with a %, which might come in handy in the next few days. And we can do things like remainder equals all of this stuff, and then echo remainder. So it's very picky in some places, but once you get through the syntax and the weird spacing details and so on, it starts to feel like a pretty normal, reasonable programming language. But if I put a space after remainder before the equals sign, it gets very unhappy. Or if I put a space after the equals sign. So be prepared to try to figure out its quirks and live with them. I'll try to be extremely consistent in how I do things in shell up here when we're talking about shell programming and such. But there are so many different ways to do most of what we're doing. Okay, when we get to if statements, which we'll do in a few minutes, there's at least 5 or 6 totally different ways you can write an if statement in the shell. I'm going to stick to one way of doing that, and I'm going to suggest that you stick to that way also. And it's not that that's the only way or it's the best way, but if you go to Google and you say, how do you do an if statement in Bash, you'll see some different way to do it. You start doing it like that. If you go back to the videos or your notes and try to make sense out of what we're talking about in here, it's not going to make any sense, right? Because your code's going to be doing something totally different. If you're already comfortable with Bash programming and you already have your own way of doing ifs, that's fine. I'm not worried about that, right? I'm not saying you got to do it this way, but if you're learning this for the first time, I strongly suggest sticking to the style that we're using here. Okay. All right, well, let's do some if statements. So let's build a script with a high security interface to stop unauthorized people from getting in. So we'll start off, we'll say welcome, enter the secret code, and then we'll say read code. And now we want to know if they entered the correct secret code. So what should our secret code be?
1, 2, 3.
Okay. Don't write that down because it's secret. All right, so we want to know if the code is equal to 1, 2, 3. Okay, so if space, bracket, bracket, space. That's the weird syntax. $code space equals space 1, 2, 3 space bracket, bracket. And if you change that, it may or may not work. The worst part is if you change it, sometimes it'll still work, but only sometimes.
So there's spaces in between everything.
For this statement, there's spaces in between everything.
And every one of those spaces matters.
And every one of those matters, yeah. And like I say, if you take some of them out, it may still work sometimes, but in other cases, it will fail. And we're going to modify this in a minute, but this is our first version of it. Okay, new line, then. New line. Now we get to put in all the stuff that we want to do in the then clause. And I'm going to indent. Leading spaces are ignored, but I'm going to indent just to make it easier to sort of know what goes with what. Echo, you got the code right. And I'll have my cow welcome me. Else, okay, otherwise I'm just going to say wrong. And then to end the whole thing, you do if backwards, phi. I don't know why. I never liked that, but it works. Okay, so there's a basic if then else statement in bash. If condition, then stuff that you want to do, else stuff that you want to do.
Or what's FI?
Fi is the end of if.
Okay.
Right, so that's like the closing bracket in C. All right, so there's my program. Let's go ahead and run it. So it says welcome, enter the secret code, and I can put in 124, and it says wrong. And I run my program, and I put in the correct secret code, and it says you got the code right, welcome. Yeah. So we're most of the way to a complete programming environment now, right? Any programming environment, you need three things. You need sequential statements, you need conditionals, and you need looping. And looping's no harder than doing this stuff.
What would you do looping in this?
There's for statements, there's while statements, there's until statements.
Oh, okay.
So, and it's just a matter of nailing the syntax.
I did it the long way. I started in C.
You started what?
Well, I said I started my OGP.
Yeah.
I did it all in C.
Oh, okay. Well, the programming assignment 2 is going to be the same as 1, but in C. So, save your work.
Okay. Fine. That's good.
All right, so my program, welcome, enter the secret code. That worked. That shouldn't have worked. But anyway, sometimes that blows up. I was hoping it would. All right,
Maybe
so
try something other than 1, 2, 3.
say again.
Maybe try something other than 1, 2, 3.
Yeah, I tried 1, 2, 4, and
Well, I was saying for like the
In
empty
here?
space that you did.
sure. Okay, so what's a better secret code?
Cow.
Cat?
Cow.
Cow. Oh, good one. All right, so 1, 2, 3. Oh no, they changed the code on me. Dang. Okay, how about cow? There we go. All right, so we can prompt for input and we can get values in using a read statement, and we can start doing tests on that. right? So let's make this slightly more interesting. So let's enter a number. Let's read num. I could have called it code. I'm just picking random variable names. So remainder equals $paren num %4. And while we're in here, right, remember everything that starts with a number sign, or anytime it finds a number sign, it ignores everything after that. So we can make comments like this. So let's start commenting our code. This is a demo program. Google will buy this from me for a bunch of money. And blank lines are ignored also, right? So, how much have you talked about commenting, like in 121? Was that a big deal? A little bit.
Slash.
Yeah, the double slashes.
Zero double slash or the slash asterisk.
Or the slash asterisk, yeah, and then you end with an asterisk slash, which is kind of like if and phi. Actually, I never thought of that because it's slash star reversed. Interesting. When you write code, right, so this is a creative process, right? Part of that creative process is your coding style. And I really want you to explore and develop your own coding style in this course, okay? Now, I can write programs like we've been writing with everything moved all the way over to the left and no spaces and no comments, and it will work just as well as any other version, okay? But when you go to read the code, it's easier to read and understand what's going on if, for example, there's a block of comments in the beginning with, you know, a description of what the program is and maybe the date and your name and things like that. And I'm going to continue, so get a number from the user. And here I'm going to say, see if it's divisible by 4. Yeah, I have a nice Cherry keyboard at home, and I'm not used to this. See if it's divisible by 4, so I'll calculate the remainder. So if $remainder equals 0, then your number was divisible by 4. Else your number has a remainder of remainder and divided by 4. Should that work? Yeah? Alright, so enter a number. Let's enter 24. It says your number was divisible by 4. That's good. In the program, let's enter 25. Your number has a remainder of 1 when divided by 4. That seems to work. So our program's getting a little longer, right? More details, but fundamentally kind of the same thing we've been doing. Enter a number. There's the cat on the keyboard. My number was divisible by 4. Well, that's probably not a good thing. So what's going on here? Why does it think that GJHGK is divisible by 4? Well, there's no strong typing in shell scripting, right? Variables or whatever they look like. And what's happened is, right, we set x to some big long string like that. What happens if we try to do arithmetic on that? Let's try adding 1 to that. We get 1. If we do that, we get a 5. If we just echo $paren x, we're asking the system to evaluate x as an arithmetic expression, and this thing with all these s's, d's, and j's in it, it doesn't know how to evaluate that, so it just makes it a 0. But we can take advantage of that. So let's add something in here. What we'd like to do is know if the number that the person entered is actually a number or if it's some gibberish. Okay, we want to know, did they enter a number or did they enter something that's ridiculous? And we know that if they enter something ridiculous and we do a $paren, it'll change to a 0. Can we put those together to somehow do a sanity check? So who wants to throw out a proposal?
If random gibberish is 0, we could check to see if the value is 0.
Okay. So if random gibberish is 0, let's do this up here. The M key doesn't want to work. So if $paren num equals 0, or let's say not equal to 0. Now let's say equals 0, then so I'm going to tell you that that's not a number, and I'm going to say exit, which gets you out of the shell script. So it's like a return in the middle of a program.
Can you not use things like
Single quotes? Yeah, we'll come to that in a second. We got to do something to make that work. Good eye. All right, does that look good? Let's see what that does. So 24, that's still divisible by 4. 25, that's got a remainder of 1. Gibberish, it's not a number. That's pretty good so far. One detail though, if I put in a 0, something weird happens.
Nothing's happening.
Yeah,
That is an error.
that is a little weird, right? That's not the error I expected. I expected a different behavior.
We're checking for 0.
Mm-hmm.
And so it's any number including 0, or results in 0, it'll register as that.
Right, so that's the glitch that I was expecting to get, is that if you put in a 0, it's going to think that it's not a number, because we converted it to a number and compared it to 0. So, but I don't know what it's doing right now. That's weird. Very interesting. All right, we're going without a safety net here. So I think if we do a -v on bin bash, it will show us what it's doing as it executes. If it doesn't, forget I said that, but but let's try that. All right, so it's giving us a nice echo. So it's about to say read num, and we put in a 24, and it's doing all of this. Okay, so let's try this. Put in a 0. And it seems to be stuck there. That's weird.
You need to have the exit after the is statement.
If I put the exit down here, it'll always exit. And it didn't do my CalSay either.
Could be a spacing issue.
It could always be a space issue. It feels like it's stuck right here.
Before the if statement, can you put in a echo dollar sign but parentheses num? Just
Sure.
because
It's a good idea. So num's equal to 0.
I'm gonna try that.
Try what?
Try the name of not equal to 0.
That would be interesting. Let me try this and then we'll try that. So let's just put some, so this is how you debug, right? Most straightforward debug approach is just start putting in print statements. Figure out where the program is, how far it's gotten, values of variables, and so on. So num equals 0, it's doing the if, and it never comes out of the if statement. So there's something going on in here. Let's see what happens if we say not equal to 0. So if you want not equal, it's an exclamation mark followed by an equal, same as in C. So now 0 works, and if we put in something that is not 0, that seems to work too. So there's something peculiar about 0. So let's say we're doing the CalSay, and then we're exiting. So CalSay is hanging up for some reason.
What if you try CalSay as echo?
Good idea. Nice. All right, so cows can't say 0. They haven't discovered 0 yet. And we shouldn't tell them. Okay, so this kind of leads into the isn't thing. CalSay is a command, right? Commands take switches. When you say ls, you can say ls-l, for example, to do a long listing and stuff. Since we really want CalSay to get an argument which says $num isn't a number, right? We can sort of force that all into being a literal by putting it inside double quotes. Okay. So if we do that, it's going to take this thing as one argument, and that's what it's going to try to say. And if we run that, we'll get our cow behaving the way we want. And if we do that, we can also now put a single quote in there and actually say isn't. Whereas if we don't have that quote, it's going to take that, if we don't have those double quotes, it's going to see that single quote as saying I'm starting a quoted expression, and it will never find the end of it, and it'll get really unhappy. So double quotes are usually something we want to use unless we're dealing with numbers. Okay? If you're asking the user to type in their name and then you want to show what their name is, you want to put the name inside double quotes, so double quote $name. And this starts to get into security issues sometimes. And for the most part, this is pretty well locked down, but here's something that used to be an option. Read name, echo $name. And this is a script that's running on your machine, and it's available on the web, and when you run it, it asks for your name, and you type in your name, and it says, hello name. Let's make it a little more interesting. Echo, who are you? Read name. Echo, hello name. Can't get much simpler than that, right? Prompt the user, get a name, greet them by their name. Here's what could have happened in some older versions of shells. You run this, the code's running on the server to ask you for the name, you type in your name, and you say, my name is, Nick, remove all files. And the shell would take this and it would do the following, echo hello, and it'll replace $name with the value of $name, which is Nick, semicolon, RM star, and now it sends this to the shell to execute. And what is this? It's two instructions separated by a semicolon. The first one says hello Nick, the second one says delete all the files in the current directory.
So,
Oops. So this is code injection, right? It's SQL injection is the one you usually hear about. You can do this with queries on databases, right? But you can do code injection on shell scripts sometimes. And Bash has been locked down, right? Although about 4 years ago, somebody found a way to do this in like modern versions of Bash. There was still a glitch somewhere. And you could inject code and execute it doing something like this. Now, if you simply add double quotes here, this is what it gets translated into, and it's going to do exactly what you want it to do. It's just going to echo whatever you typed in. So in general, we want to use double quotes or something that turns our stuff into literals anytime that we don't explicitly need a number. So here we could right, we could do something like that. And double quotes don't stop the $sign from being evaluated. All right, so if I say something like x equals 12, echo $x, it shows me 12. If I say echo double quote $x, it still shows me 12. But if I say echo single quote $x, it says $x. So single quotes are different. They say just take this thing between the quotes and treat it literally. If there's a $x, I mean a $sign followed by an x. Double quotes will still evaluate variables using a $sign. So we can also do this in here. And in some versions of Bash, if num was empty, it would blow up if you didn't have those double quotes around. But this will basically take num and it will try to convert it to an integer, and then it will convert it into just a bunch of symbols, right? Either a 0 or the symbols of that number, and see if it's equal to 0. So let me get rid of these debug statements. All right, does that look pretty clean? So 24 is divisible by 4, 25 is not divisible by, it has a remainder of 1, and this thing is not a number. But we still have this one issue, which is if we type in a 0, the cow tells us it's not a number. So this is doing most of what we want, but we could make one change to it to take care of that case. Any ideas?
Zero would be a special case, and it has its own explicit condition.
We could put a special check in to see if number is equal to 0. And if it is, then we're okay, we just got a 0. Otherwise, we could do this thing to see if the thing they typed in converts to a 0 or converts to something other than 0.
Or you could just say it must be a number greater than 0 instead of this number.
We could, but would that still help us if they typed in something? Oh, so we could just not allow 0.
Yeah, just say it must be a number greater than 0.
Okay, we could do that. But if we want them to be able to enter a 0, right, for some reason, which we wouldn't for the number of sticks in a game, but maybe we want 0 to be a valid option.
We would have to, this would need characters and the 0.
Yeah. So you can fake it by something like this. So the thing on the left is saying take this variable num, convert it to an integer. The thing on the right is saying let's just look at exactly what they typed in. Right? If they type in any legal integer, those two should be the same. If they type in something that's not a legal integer, the thing on the left will be a 0, the thing on the right will be whatever they typed in, those will be different. So this should give us a pretty good sanity check. So numbers work fine, 0 works fine. Oh no, it doesn't. All right, before I fix it, what's the problem here? Should be unequal. Right, so if what they typed in is the same as when you convert it to an integer, then it's an integer. If it's not the same, that's when we have something that's not a number. All right, so 24 is fine, 25 is fine, 0 is fine, and things that aren't integers aren't numbers.
It said 0 is divisible by 4.
Which it is. It's 0 times 4. 0 is always an oddball case. So there's some code you can use in PA1, right, when you're trying to input number of sticks that you want to play with, or how many sticks do you want to take, 1, 2, or 3, to see if they're typing in a good number or not. All right, so we still need to talk about how to do conditionals with actual numbers. Because we know equal, equal, and we know exclamation equal, but what about, suppose we want to know if their number is less than or equal to 3. And there's slightly different syntax for that. Instead of less equal, you say dash LE for less than or equal, and dash GE for greater than or equal. So we'll play with that tomorrow, and we'll go ahead and look at some basic looping. Okay, I'll show you how to do a while loop. And it's the way that you go from a CIF statement to an if statement here. Same thing to go from a C while loop to a while statement here. It's while space, bracket, bracket, space, conditions, space, bracket, bracket. So there's a one-day program due tomorrow, which is basically a script where your cow says hello world. So just use the CalSay command.
Oh.
All right, so I'll see you tomorrow.